theorem, right? So let's see what it is. So you know about it, right? What is binomial theorem is. So you can take it like this: bi means 2 and nomial means number. So we are going to keep it a little bit faster, so just have attention over here, right? So what you can say, x plus y to whole to the power n, right? So we have to expand this. Now what you can do, so the formula is like this: nc0 x to the power n and y to the power 0 plus nc1 x to the power n minus 1 and y to the power 1 plus nc2 x to the power n minus 2 and y to the power 2, and so on. It goes like this, and in the last it will be ncn and x to the power 0 and y to the power n, right? So this is how the expansion work. So in order to understood it, just substitute the value of n as 1, 2, 3, right? So these three will be very okay to understood what it is and how the expression is going on, right? So you can do it by substituting the values of n. So it will be easy, you know, when you forget the like this, right? So this is how you can do it. Now, so the expansion like this is not so important, but from this you can conclude many of the things, right? So what I am gonna do is I am going to substitute y as x. Okay, y as x. So if you y as x and x as 1. So you can write it like this: 1 plus x to the whole power n. So this is very important expression for coming binomial theorem. So this is very important, right? So please pay attention over here. So 1 plus x to the whole power n. So you can think it like I have substituted y as 1, right? So designate it like this. So what it is going to be? It is going to be nc0. If you follow the same thing, in place of x there is 1, and in place of y there is x, right? So whatever the power of 1, it is going to be 1, right? So it is just going to be nc0 and x to the power 0, right? I am not mentioning here 1 as because 1 to the power n is going to be 1, right? So whatever the power of 1 is, it is going to be 1. So that is why I am just doing it over here, right? So nc0 this. Now nc1 x to the power 1 plus nc2 x to the power 2, and so on, right? So in the last it is going to be ncn x to the power n. Okay, so the expansion is like this. So if you just substitute the value of x as 1 and y as x, you are going to get this expression, right? This expression. So 1 plus x to the power n is this, right? So this is how you can write it. Now there is a question. So what we will do is we will just solve, keep going by solving some question also, right? After like this, you will know about it. Okay, so 1 plus x to the whole power n is this. Now the question will be like this. So this expression is important. Okay, so the question is like this. They will give you something like this, and they will say you to find sum of all the coefficients, like this type of. Okay, so what I mean is, let's say 2 plus x to whole power, let's say 15. Okay, and they will ask you expand it, and whatever the coefficient of x you get, add them. Okay, all the coefficients of x means you are going to get the x and their coefficient, x to the power 1 and their coefficient x to the power 2, because these are the coefficients of x. These are these. Okay, so they will ask you to find the sum of all these things, right? So what you have to do is you just have to substitute x as 1. Put x equals to 1, right? So now if you substitute at x equals to 1, so what it is going to be? 1 plus 1, 2. So 2 to the power n is equals to nc0 plus nc1, because 1 to the power 1 is this, plus nc2 plus nc3, and so on, ncn. So please remember this, right? So 2 to the power n is equals to nc0 plus nc1 plus nc2 plus nc3. What is nc0, what is nc1, what is nc2? They all are the coefficients of x. Okay, what they are is coefficients of x. So you may think that what happened if the question is like this: 1 plus x upon 2 to the whole power, let's for example, let's say 3. right? So if you expand it, it is going to be 1 plus x cubed by 8 plus what it will be 3 x square by 4 plus 3x by 2. This, the expansion will be like this, okay? Or I should write it in this way. Just keep it over here, okay? So x cubed by 8 plus 3x square by 4 plus 3x by 2 plus 1, right? So now the coefficients are like this: 1 upon 8, 3 upon 4 plus 3 upon 2 and 1. So we will take it as a coefficient of x to the power 0. Now the sum of these are equivalent when you put x equals to 1 over here, right? If you put x equals to 1, so it is going to be 1 upon 1 plus 2 to the power 3, and you are going to get same expansion: 1 ka cube, 1 upon 2 ka cube, 3, 1 square, this and this. Okay, so no worries. If they ask you to find the sum of all the coefficients in the expansion of some binomial term, then you just have to substitute the variable equals to 1. These are the variable, and this will work fine if you put x plus y equals to, so let's say 2x plus y is equals to 3, and still they want you to find the sum of all the coefficients. You just put x and y both equal to 1, right? So you can think of like this: if you expand it, it is going to be 8x cube plus y cube plus 4 3 12 x square y plus 6x y square, and the sum of coefficients are 8, 1, 12, 6. Okay, and if you put x and y as 1, so it is going to be 2 plus 1, 3, right? 3 to the power 3, which is 27, and let's add them: 8 plus 1, 9, 12, 9, 21, and 6, 27. So both are going to be same. So in the expansion of binomial, having any number of variables, if you just substitute all variable equals to 1, you are going to get the sum of all the coefficients in the expansion of that particular binomial term, trinomial term, or anything. Okay, so this is how it is done. Okay, so remember that. So put x equals to 1, 2 to the power n is equals to this, and this is sum of all coefficients. Coefficient is used for the variables. The multiplication, the multiplicative terms of variable is known as coefficient. So whenever coefficient comes, you have to think it like this way: sum of all coefficient in the expansion of binomial term, in the expansion of just write it like binomial. Okay, so you have to keep it in your mind. Now put x equals to -1. If you put x equals to -1, this whole term is going to be 0. So this implies that 0 is equals to this x is -1, right? So it is going to be -1, but -1 to the power 0 doesn't mean anything, right? So it is going to be nc0. Here it will be negative, so minus nc1, and here it is positive. Even term is going to be positive and odd term is going to be negative, right? So minus this plus nc2 and minus nc3 and so on, right? So this is and so on. Okay, I'm not writing it like what it is. If you're considering n as a odd number, if n is going to be an odd number, then last term is going to be negative, otherwise it is positive. So please keep this in mind. Because it is going to be a little bit confusing. So if you understood the concept, that will be better to interpret it what it is. Okay, in the expansion, in the exam. So this is how it is going to be, right? So remember this also. The alternative, if you changes the sign in the expansion of binomial, alternatively their sum is going to be 0. Okay, so what does it mean, right? So you can write it like this way: 0 is equals to nc0 plus nc2. I am taking all the odd terms, first term, third term, fifth term, odd terms, right? nc0 plus nc2 plus nc4 and so on. Sum of coefficient which is at odd place, minus, take minus as a common, so nc1 plus nc3 plus and so on, right? And these are the coefficient which is at even place. So this implies that nc0 plus nc2 plus nc4 is and so on is equals to NC1 plus NC3 plus NC5. So this one, right, and so on. So sum of coefficient at odd place, which is present at odd place, and this is sum of all the coefficient at even place. So these are the very simple thing that they may ask. Okay, and one more thing, you know about it, right? What is NCR is? NCR means n factorial upon r factorial n minus r factorial. So this just I want to explain, because maybe you have forgotten this. So please keep in mind. So sum of coefficient at odd place in the binomial expansion is equal to the sum of coefficient at the even places. So, and what is the values of this? These have some values. So I want you to know what their values are. Okay. So means what is the value of this? What is the value? They both are equal, and what their values? Try to think it about this and try to find it by yourself. I'm just gonna solve it, but you try to solve it by your way. Okay. Now, okay, I'm just rubbing this part. You better note it down. Now, okay, so now add these two. If you add them, 2 to the power 0, because these are same, and these terms will cancel out. All the even place terms are cancel out. So NC0, twice of NC0, plus twice of NC2, plus twice of NC4, plus and so on, right? So 2 to the power 0 is equals to 2 upon NC0 plus NC2 plus NC4 plus and so on, right? So if you keep this over here, so it is going to be 2 to the power n, it is n, 2 to the power n minus 1, and it is equals to NC0 plus NC2 plus NC4 plus and so on. And which term they are? They are the terms that are at odd place, right? It is the first term, it is the third term, it is the fifth term. Okay. So like this, right? And these terms, so their values are 2 to the power n minus 1. Now this value is actually equal to the sum of coefficients which are at the even places. So NC1 plus NC3 plus NC5 plus and so on, right? So they directly can ask you if 2 plus let's say the question is like this: 2 plus 3x to the whole power, let's say 15. They will ask you to find the sum of all the coefficients which are present at the even places. So whether they say even places or odd places, the answer is 2 to the power 15 minus 1, 14, right? So that will be the answer. So this is how you have to do this. Okay, right. Now you can note it down. So please keep in mind they are very general, and they are asked very frequently. Now, so these are little bit important, and we will come here again. But before that, there are some important terms that you should know. Right? In the expansion of x plus 5 to the power n, right? The expansion is like this. Now try to follow the pattern. If in this expansion, this is 0, this is 1, this is 2, right? And so on, they are going to be like this. So how many terms are there? Okay, so in the expansion of x plus 5 to the power n, you will find that the number of terms is n plus 1. Okay, and for your just generalization purpose, what you can do is x plus y to the power 2. How many terms will be there? 3. So x plus y to the power 3. How many terms will be there? 3. Oh, sorry, 4. Right. So the total number of terms is going to be n plus 1. So in the expansion of this, the total number of terms is going to be n plus 1. And from here, a question arises like this. So let's say I have some terms x1 plus x2 plus x3 plus and so on. Let's say xm to the power n, and I want to find how many terms are there in the expansion of this. Okay, so the answer will be like this. What it is? m plus n minus 1 c m minus 1. Okay, just keep this in your mind. So what you can think, how can you do this? Now see, you just better take an example of x plus y to the power 2, x plus y plus z to the power 3, right? And try to put the values over there. Okay, so that is how you can interpret what the formula it is. Okay, so this is how you can do this. Now next thing, so we know what the number terms are. So there are two terms and x plus y to the power n. There are two terms in the brackets. Okay, so that is why they are known as binomial. If there are three terms, okay, so it is possible like this: x plus y plus z, x plus y plus z to the power 3. N. So how many terms are they are known as trinomial. It is binomial, it is trinomial, and the extension of this. Okay, so in the expansion of this, how many terms are going to be? N plus 3 minus 1, which is n plus 2 actually, because there are the value of m is 3. There are 3 terms, so it is going to be n plus 2 c2, right? So n plus 2 c2 is the total number of terms. So they may ask us like direct questions on this. Okay, so you should know that this and this. This is the first term, this is the second term, this is the third term. The question you in your mind may arise is how I can find the kth term, right? So this is the first term, this is the second term, third term. Let's say I want to calculate the 10th term. Okay, so there is a formula, but before directly going to the formula, because like this, I write it down like this, but you understood it like this way. If you substitute x plus y to the power 3, like 4, and then x plus y plus z to the power 2, and then if you solve, then you will see the pattern that they follows. Okay, now in this expansion, again try to see if there is something that is going to be followed. Like here the power is n minus 1, n minus 2, and so on. The power of x is going to be decreasing by 1. Okay, and the power of y is keep increasing by 1, right? And it is NC0, NC1, NC2. So this is how they are all following some rules. Okay, so using that you can directly find their nth term. Now, so there is something important. So this is also known as general term. Means in the expansion of x plus y to the power n, I want to find general term tr plus 1. So why r plus 1 has been introduced? So I will tell you later. So it is going to be ncr x to the power n minus r and y to the power r. So if you put if you want the first term, there should be 0. If you want second term, it should be 1. And if there is a third term, then this value should be 2. Okay, so whatever here, if I want r plus 1th term, then it should be rth term, 1 less, right? But if you want, like suppose 0, for suppose if you like it like write it like this, tr, then it is going to be ncr minus 1. Okay, because according to this, whatever here it is, means if it is the rth term, then there should be r minus 1. Okay, so first term, for first it is going to be 1, right? R is going to be 1. So this is how you this is more means this is not very familiar to use like this. So it is then the formula becomes a little bit complex, n minus r minus 1 and y to the power r minus 1. Okay, so better way that they introduce is tr plus 1 equals to ncr x to the power n minus r and y to the power r. Okay, so that is more familiar way, that is why they goes with this. Okay, so tr plus 1 is equals to ncr x to the power n minus r and y to the power r. You can see it like this. Okay, so this is how you can find the general term, right? For the extension of this, if you want, let's say 15th term, t15. Okay, so t15 can be written as t14 plus 1. So always write it like this way. So nc14 x to the power n minus 14 and y to the power 14. Okay, so this is how you can do this, and 0, and this will be your 15th term. Okay, so okay, now so this is how you can find the general term, means in the expansion of something, and they will ask you to find 15th term, 16th term. You can do this, and using the same thing, let's come with an okay, what they can say is, so suppose I have a question like this: 2 plus 3x to the power let's say 16, and the question is find the coefficient of x to the power 15. You have to find the coefficient of x to the power 15, or let's say 12. Okay, so I have to find the coefficient of x to the power 12, let's say. Okay, so what you can do, I don't know which term it is, so let's say it is r plus 1th term. So it is going to be like this: 16cr, right? And here the first term is 2, so 2 to the power 16 minus r, and this is going to be 3x, which is y, and the power of this is r. Okay, so in order to get the coefficient of x to the power 12, there should be x to the power 12 in that particular term. In order to make x to the power 12, we have to substitute r equals to 12. Okay, so I have to put r equals to 12. Now at r equals to 12, right? So t, it is going to be 12 plus 1, and this is going to be 16c12, 2 to the power 16 minus 12, and it is going to be 3x to the power 12. Now, so it is going to be 16c12, 2 to the power 4, and this can be written as 3 to the power 12 and x to the power 12. Now what is the coefficient? This term is the coefficient. Okay, so this is how you can do this, right? To find the coefficient. So so first of all, from the expansion, what you get? Total number of terms, the general term, how many terms are going to, means how can you find the any term in the expansion, and using that things, you can also find the coefficient, right? So this is how you can do this. This is a general terms. Okay, right. Okay, next thing is middle terms. Sometimes they ask you to find the middle term of the terms in the expansion also, right? So x plus y equals to n. The total number of turning is going to be n plus 1. So there are two cases when n is even. So if n is even, okay. So if n is even, then what will happen? N is even. So n is even. So total number of terms is going to be n plus 1, and it is going to be odd, right? N plus 1 is going to be odd. So you know that if there are 7 terms, then which term will be the middle term? 7 plus 1 divided by 2. That term is the middle term. If there are 7 terms, then 7 plus 1 divided by 2 is going to be the middle term. So that is why the middle term will be, which one will be the middle term? So n plus 1 is the odd, so n plus 1, that is the total number of terms, plus 1 divided by 2. So this can be written as p n plus 2 divided by 2. So which is equals to p n by 2 plus 1. So this term will be the middle term in the expansion of this, and because if the total number of terms is odd, then there is going to be only one middle term. So that is the only middle term, and the expansion could be like this: n c r. What is r? R is n by 2. So x to the power n minus n by 2, right? N minus n by 2, and y to the power n by 2. So it is simply like nc n by 2, and x to the power n by 2, and y to the power n by 2. Okay, so this is how you can calculate the middle term. But if n is odd, then total terms is going to be n plus 1, which is even. And you know that if there is even number of terms, if there exist even number of terms, then there is two middle terms. Okay, so two middle terms, and they are, if let's say there are 6 terms in total, then which terms are middle term? So first is 6 by 2th term, and other is 6 by 2 plus 1th term. Okay, so these both terms are the middle terms. So that is why there are two middle terms if total number of terms is even. So as total number of terms are even, then the first one is n plus 1 by 2. Okay, so this one will be the first, will be the middle term, and other one is n plus 1 by 2 plus 1. Okay, so total term divided by 2 and total term divided by 2 plus 1. So in that case it is going to be, you can write it like this, n minus 1 by 2 plus 1. You can write it like this way. Okay, yeah. So it is going to be nc n minus 1 divided by 2, and x to the power n minus 1 divided by 2, and y to the power n minus 1 divided by 2, and p n plus 1 divided by 2. This is going to be the same, right? So nc n plus 1 divided by 2, x to the power n minus n plus 1 divided by 2, and y to the power n plus 1 divided by 2. So this is how you can do this. Okay, you please subtract it for the simplification purpose. You can do this. Okay, so this is how you can calculate the middle term also. So you can find it in this way, right? So okay. Now sometimes the question is so please make the heading of these. Okay, so these are the middle terms. So so two possibilities are there based on the power value of n. If n is odd, then there will be two middle term, and if n is even, then there is one middle term only, and this is how you can get it. Okay, so some questions they ask is ki, find the term find the greatest coefficient. Okay, find the greatest coefficient in the expansion of some expression. So if you expand anything, like if you substitute x plus y is equals to this, x plus y is equals to this, and yes, x plus y to the power n. So you will see that the middle term always have the greatest coefficient. Okay, so just for illustration purpose, I can show you like this: x plus y whole square and x plus y whole power 3. So it is going to be x square plus 2xy plus y square. Okay, and x cube plus 3x square y plus 3xy square plus 3y cube. So there are the power is 3, so the total number of terms is 4, and as total number of terms is 4, which is even, there will be two middle terms. So these two are the middle terms. Similarly for here, the total number of terms is 3 because the power is 2, so the middle term is only 1, so the coefficient is 2, the coefficient is 3. So these are, so you can do it for x plus y to the power 4 also. You are always going to get the middle term having the maximum coefficient. Okay, so if they indirectly ask you to calculate the term, or they ask you to find the maximum coefficient in the expansion of something, then you have to basically calculate the middle term. So remember that in x plus y to the power n, in x plus y to the power n, the middle term will have maximum coefficient. So I told you how to calculate middle term, then you can easily find what is the coefficient is. Okay, so this is how you can do this. Okay, so please remember this. Now some questions are like this. 1 plus x to the power n. So you know that what is the value is nc0 plus nc1x plus nc2x plus nc3 x square, okay, x square, x cube, and so on. For last it is going to be ncn, x to the power n. So there are two types of question that may be asked is based on differentiation and integration. So you know that, okay. So how to do this? So based on differentiation. So how the question is? So differentiate it once. So if you differentiate it, it is going to be n, and 1 plus x to the power n minus 1. 1 plus x to the power n minus 1 is equals to the differentiation of this part is 0, and for here it is going to be just nc1 plus 2 into nc2 x plus 3 into nc3 x square plus and so on, and in the last it is going to be n x to the power n minus 1. Okay, so if you so, and they may ask you to find the value by putting x equals to 1. Okay, so if you put x equals to 1, put x equals to 1, so it is going to be n into 2 to the power n minus 1, which is equals to nc1 plus 2 into nc2 plus 3 into nc3 plus and so on, which is going to be n, and because x is going to be 1, so it is just going to be n, and you can write it like this, n into ncn. Okay, so this is very interesting, right? So they directly ask you to find the value of this. Okay, so not this exactly, so maybe they can differentiate it once more, okay, and then they will give you this, or what they can do, they can give you x as a coefficient of x by 2. Okay, so what happened, it is going to be x by 2, it is going to be x square by 4, like something like this. Okay, so you should know that how to use differentiation. The basic thing is the coefficients, means the coefficients like nc1, nc2, nc3. So if they are differentiated by first only one time, it will start with nc1. If it has been differentiated 2 times, then it will start with nc2, and their coefficients are being multiplied by some number, and these numbers as differentiation increases, they are like factorial. Okay, c1 so it. Okay, differentiate it again. So n into n minus 1 and 1 plus x to the power n minus 2. And now if you differentiate this, so this is going to be 0, and this will become 2 into nc2, and here 3 into 2 into nc3 into x plus 4 into 3 into, okay, that should be 4 into 3 already. 4 into 3 into nc4 and x square. So this is how it happens. Okay, so 2 into this is this, and so how will you know about it? Okay, it is basically 1 into 2, right? And so this is how you can think of 1 into 2, 3 into 2, 4 into 3, means this type of, if the numbers are like this, so that they are the multiplication of 2 successive terms with their coefficient, then you can interpret that they are being differentiated and from some values. So you have to find basically what it is. Okay, if you know what it is, then you can interpret this. Okay, so by practice we will solve some question on this, and that will become very easy. Okay, so this is how you have to use differentiation. And now let's see how integration work over here. Okay, all right. So you do one thing. You just take any value with one variable only. Okay, so they are basically applicable for single variables. So you write it like this: 2 plus 3x to the power and then differentiate it and then get the values. So by practice it will be very clear to how to solve them. Okay, so differentiation is used in binomial theorems like this. Okay, now the next thing is, okay, so 1 plus x to the power n. Now we have to use integration, and let's see how it works. So in the 1 plus x to the power n, so alright, So if you integrate this, this is going to be 1 plus x to the power n plus 1 divided by n plus 1. And if you integrate this, so it is going to be nc0 x plus nc1, or you can write it like this, x square by 2 plus nc3 upon, sorry, nc2 upon 3 and x cube and so on, ncn x to the power n plus 1 upon n plus 1. So the major difference between these two, the expression, that expression in differentiation, the overall degree decreases by 1, because in differentiation, what is the degree of this? X to the power n, right? So this will differentiate one time and the degree becomes minus 1, means less than 1, less than n, basically 1 less than n. So in this case the degree increase. So this is how you can interpret. And one more thing, they are being divided by some particular values, 1, 2, 3, like this, powers. Okay, so this is how you can think where integration is performed or not. So what they will do, they will substitute some value of x. They can substitute any value of x basically. Okay, and then they will ask you to find the value of the particular expression. Okay, so this is how it happens. Okay, so what I am going to do, I am going to do a question, try to solve it. Right. So the question is like this: nc0. This is going till n terms. So nc0. 2nc0 plus nc1, 2nc1 basically, plus nc2, 8nc2 upon 3, 8 into this, right? So this is going to be nc3 upon like this. Okay, so this is going to be till n terms. Okay, so it is something like this: 2 to the power 2 nc0 into this plus 2 nc1 plus 8 into nc2 divided by 3 plus 4 into nc3 and so on. Right, so these are till n term, till nc terms. So you have to find the value of this. So what I have done is, I have just substituted the value of x by 2. So if you substitute x equals to 2, right, so what will happen? It is going to be 2 plus 1, 3. So 3 to the power n plus 1 divided by n plus 1. So our answer is like this. Okay, so this is how you have to do it. Okay, and one more thing, if the question is asked in option type, so you basically substitute the value of n also. Right, so in that way it becomes easier, right? If you substitute n something, and if you try to if you substitute n equals to 2, then these 3 terms you have to calculate and compare with this by substituting n equals to 2. Yes, n equals to 2, and if both are becomes equal from options, then that will be the answer. So this is how you have to do, and this is how you have to introduce integration in it. Now what you can do this once more. If you integrate once more, so this is going to be 1 plus x to the power n plus 2 upon n plus 1 into n plus 2. So I guess you know about the integration, so I'm not going to explain it. So nc0 x square by 1 into 2, nc1 x to the power 3 upon 2 into 3, and nc2 x to the power 4 upon 3 into 4. So this is how it had to be done. Okay, so this is how you have to perform integration, and they will substitute the value of x. So you try to solve it by yourself. Okay, you just substitute x value of x and calculate the values of this. Okay, for the expansion also. So this is how you have to do. After all, we have some special expansion also, right? In binomial theorem, to how to expand them. Okay, so we are also going to see them. So this is how you have to do. Okay. So one of the important question is like this: 1 plus x to the power whole power n, where n is fraction. N is in fraction. Okay, so the important thing about for here is fraction. So 1 plus x to the power n. Okay, so what you can do? So the formula is like this: 1 plus nx So actually it is like this, 1 upon 0 factorial, and here it is 1 factorial, and here it is n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x square, x cube, okay, and so on. This was keep increasing till infinity basically, okay, because the power is fraction, okay, so please keep this in mind. So the power is going to be fraction, right? So this is how you have to do. And sometimes there are some questions that has been seen, they ask the fifth term or 10th term, right, in the extension of this. For example, the question is like this, 1 plus x to the power minus 2, and they will ask you to calculate its fifth term, sixth term. Then how you're going to do this, okay? So you please try to solve it by yourself. 1 plus x to the power minus 2, you have to write its expansion basically. So okay, so I'm just writing its rth term, okay. So what will be its nth term is, okay. So what you are going to see, if it is 1 2 3 4, right? So if there is fourth term, then the factorial is of so I'm writing like this, nth term, okay. So don't mean it by tr plus 1 terms, I'm just writing like this way, tn. If you have to find the fourth term, okay, so the expansion should have fourth term have n minus 1 factorial, okay. Don't write it like r and have something like different. So I'm writing like this, so r minus 1 factorial, right, and it is going to be n into n minus 1 into n minus 2 into till the by means so if it is fourth term, so it is going to be n minus 2, so it is going to be n minus r plus 2, right? So these all terms will going to be multiplied, and the x to the power n r minus 1. So this is how the nth term will look like, right? And the important things, 1 minus x to the power, let's say n, okay. So n could be fraction over here, so if 1 minus x, so just substitute it over here, 1 minus nx. Why? Because x is minus, right? But here there will be no effect. Why? Because x is minus x and the square is going to make it same. So n into n minus 1 upon 2 factorial, like this, and here it is going to be negative. Why? Because x is negative. So minus n into n minus 1 n minus 2 upon 3 factorial, right? And it is going to be x to the power 3, and again plus, okay. So this is how you can do this, 1 minus x to the power 1 minus 1 plus x to the power n, where n is fraction. So important thing is this, n is any fractional value. So the question is like some questions are like this. So one interesting question is like this, 1 plus x square to the power 3, and plus something like this, or let's keep it minus 3, okay. So some question is like this. So the question they may ask you is find the coefficient of x square. I don't remember what exactly question is, but I can tell you how to solve it. So 1 plus x square is basically, this can be written as x cube minus 1 upon x minus 1, okay. So you know that x cube minus 1 have a factor, x minus 1 into 1 plus x square, okay. So this is the formula basically, okay. So if I take the value of 1 plus x square, so it is going to be x cube minus 1 upon x minus 1 to the power minus 3, okay. So what I can write it like this, because of minus power I can write it, okay. So this can be written as x minus 1 upon x cube minus 1 to the power 3, okay. So now you do this, x minus 1 to the power 3, and this will become x cube minus 1 to the power minus 3. For here you can expand this, right? So for this particular thing you can write it like this way. Now expand this by using this, okay. So this is how you can do this.